or numerical variable.
Okay, so we are saying a variable, or what we call a random variable from now, is represented by the letter X. So in all our probability distribution functions, so we shall always see a letter X appearing. So that letter X will be representing a random variable. And we are saying it represents a numerical or a quantitative variable. So we are going to be using it for values, numerical values like 1, 2, 3, 4, 0 onwards. That is when we are under discrete. So we are saying there is a question there that what is the difference between discrete and the continuous data? So what could be the difference between discrete and continuous data? The difference between discrete and continuous data. I have an answer in the chat. Okay, I'm going to send it, please. So from what is written here, we are saying discrete data can only take on particular values in a range. So with particular, we are majorly referring to numbers that we can easily count. So like, for example, 0, 1, 2, 3, 4. So when you meet those numbers and they are in a probability distribution function, then that function is discrete. In other words, it is a probability. Okay, it is a discrete random variable. Then with continuous data, it takes on values. Continuous data can take on any value in the range. So if we are maybe interested in numbers from 0 up to 3, so it takes on very many values. So very many values, maybe if I can illustrate on a whiteboard, let me share it briefly. So if we are told to write numbers between 0 and 3, so which numbers do you think will be included in here?
1 and 2.
1 and 2. Okay, that is one of them. So 1 and 2. Samuel, which numbers do you think are going to be included? Because we said it takes on any value within the range.
Even 0.5.
And then 2.5, 1.5, then 2.5.
Okay. So still, we could as well begin from 0 to 0.5, and would still write some other numbers there, 0.1, 0.2, 0.3, up to that. So do we notice that as we keep on writing these numbers, it might be an endless process?
Yes.
Yes. So this one, we call it continuous PDF. It is continuous PDF. And later we shall come to it, but maybe before we go any further, I wish to know if, because for Samuel, I think I haven't taught you integration. Karen, did you do some integration at school?
Yes.
Okay. So Muhumuza, we should get a day next week and we do integration, because later we shall need to use it when we come to the discrete PDF.
Yes, I think probably I would want or to do that. I don't
Okay.
know. Should I contact you after the class? Is it okay?
Can we have it tomorrow?
Yes, bro. Yes, we can do that because I
Oh.
need that.
Okay.
Integration is a bit complicated, so I have to do that.
It is simple.
It is simple to by saying addition, increase, decrease, subtraction, whatever, but I think yeah.
Okay. Okay, we shall see that. Let me again share the work on the site. So that we are talking about briefly the difference between discrete data and continuous data, and we have seen that. So we have examples of each. So I'm saying how tall is a plant given a new fertilizer. So I'm saying that is continuous. This is something you can measure. I think something you can measure. So it keeps on increasing. Then how many fleas are on parry dogs in a colony? So discrete. So measure something you can count is discrete, something that you cannot specify, because when you are trying to measure a tree using a ruler, the ruler has some decimal points in them, so that is why they are calling it continuous. So something that cannot be counted. So here we shall regard it as continuous. Then this image just brief again talks about what we have said, the random variables. So here we are beginning with the discrete. So I'm saying a discrete random variable, RV, assigns a numerical value to the outcomes in a sample space of a random phenomenon. So I'm saying a discrete has a finite number of possible values. So for example, when we toss a coin and we are interested in getting the number of heads that may come up, tossing it a number of times, then we are able to record that the head has appeared 2 times, or none, or 4. So that one will fall under a discrete random variable. And then we are able to later draw a table like this. I'm going to share some slides that I prepared. So here we have X, which stands for those values that we can count, but this one, okay, this one we shall meet it later in binomial. So briefly, that was the introduction. So later you should come open this course unit here, and then you'd be able to watch these videos and do some reading. Is that okay?
Yes, it's fine.
Okay, so let me share something else here. So we are looking at applied mathematics. So we are beginning with properties of a discrete random variable, which are a key aspect of this lesson. So we are saying if X is a random variable, as we have said in the beginning, then we have summation. When we sum up probability of X equaling to a small x, this one should give us a 1. So this is not something new. We have always said total probability is equal to 1. So likewise, when we come to functions, probability functions, so still when we add them, they are going to be equal to 1. So that is our first. Then probability of X equaling to x is going to be equal to, is going to be greater or equal to 0. So we say the probability cannot be a negative. We can't have negative chances of an event happening. So it should be between 1 and 0. So here we are saying probability of x capital being greater than x small is greater or equal to 0. So the probability can either be 0, 0.1 up to 1. So here we are going to begin with the probability. So given that the coin is thrown 3 times and x is the number of heads that are obtained. Okay, and now our interest is to find, to have it in a discrete, in table form, and then later. So if we have to throw our coin 3 times, so this would be the first one, where we have either to get a head or a tail. Then the second time, still we have a possibility of getting a head or a tail. Then still here at first, if we had a tail, we can either still on the second throw get a head or a tail. So this is the second throw, so we can go on the third. So here we shall still have head or tail, then head or tail, head or tail, head or tail. And here the probabilities of getting a head and the tail are the same. So it is a half onwards. So we see that their half is 3 times. So if we want to get probability of getting 3 heads, so the 3 heads now, after we have done a summary, which some of the work we did, so this would be head, head, head. What would be the next one?
Head, head, tail.
Head, head, tail. Then
Head, tail, head.
Then
Head, tail, tail.
then we shall have
Tail.
head, head, then tail, head, tail, and tail, tail, and head, and then lastly tail, tail, and what? And tail. So
Yeah.
this will be our sample space, which we can bring and write here that our sample space will be this. So head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and then tail, tail, and tail. So our interest was to get the number of what? Of heads that are going to appear on the 3 times that we are going to throw our what? Our coin. So if x represents the number of heads, so what are the possibilities that we are going to have? What possibilities are we going to have? Okay, let me begin. So we shall have a situation where we have no heads, okay? So we can throw, a tail appears, we throw again, a tail appears, we throw again, a tail does what? Appears. So probability of x equaling to 0, meaning where we shall have no heads. So that is where we have x equaling to 0, and we are saying that is given by tail, tail, and tail. So remember we said the probability is a half, so this would be a half times a half times a half, and that is what gives us the 1/8 that we are able to see here. Is that okay?
Yes.
Okay. So after that, after getting 0 heads, what could be the next?
One head.
One head. So we still go upwards here in our sample space, and we get those outcomes that are giving us one head. So which ones are those?
Tail, head, tail.
So we have head, tail. This one here?
Then head, tail, tail.
Head, tail, tail. Head, tail, tail. And then we have tail, tail, head.
Tail, head, tail.
Are they the only
one-
ones?
The one before that.
Okay. So meaning those are how many?
Three.
These are 3. And then times, because their probabilities are the same, so times 1/what? Over 8. So probability of x equaling to 1. So where we have one head, so head, tail, 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 head, tail, and then tail, tail, head. So those would be 3, and then our probability is 3/8.
Eight.
Okay, then the next one is where we shall have 2 heads. That is probability of x equaling to 2. Those ones are also going to be 3, which is head, head, tail, head, tail, head, and tail, head, head. Okay. So
Yes.
still that would be 3/8. Okay, what will be the next one?
The next one is 3 heads.
3 heads. And that would only be once, while we have head, head, head.
Yep.
And then its probability would be equal to 1/3.
8.
Okay, 1/8, sorry. Then after that, we are saying this information can be best illustrated in table form. Okay, so the table is here. So we have the x, which is representing the number of what? Of heads. Then we have probability that this x is equal to a small x, so that probability. So for 0 heads, we said this was 1/8. For 1 head, it was 3/8. For 2 heads, it is 3/8. And then for 3 heads is 1/8. So we can find out if we do the summation whether it will give us a what? A 1. So would it give us a 1? If we go to 1/8 plus 3/8 plus 3/8 plus 1/8.
Yes, gives 1.
It gives us 1. So that confirms that summation of probability of x equaling to smaller x, this is equal to what? To 1. Then after that, in a discrete random variable, we as well find mean, okay? And here we call it expectation. We call it expectation. So we are saying the mean of a discrete random variable is sometimes called expectation and denoted by E capital what? X.
X.
Yes, and then we define it as summation of x times probability values. So we define it as x times probability values. Is that okay?
Yes.
Then from that, we go to variance and standard deviation. How did we use to get variance in statistics and descriptive statistics? Who
From the
remember?
logbook.
From the logbook. Hey, paper 2. Okay. So what if in the paper you forget to go with it, or it is not there? What would happen? Or it cannot happen. Okay.
It would be no disappointment.
It would be a disappointment. Okay.
Exactly, and I think it would. Okay.
It's okay. It's okay. So we are saying variance here is given by expectation of x squared minus expectation of x squared. So here we need to differentiate between the two. So this first one here, the squared is on x. Okay. Then the second one, what is this that is inside? It is
Mean.
It is mean. So we get the mean squared. Then this expectation of x squared is defined by, so we are going to get x squared, the value of x in the table, we square it, and then we multiply by the probability value. Let me repeat it again. So we get the x squared, so we get the value of x and we square it, and then after we multiply by the probability values. Then after that,
Okay.
we add them up, so we sum them. So generally, if we substituted this one back, that here I forgot to square, so it would be summation of x squared times probability minus summation of x times probability, everything squared. But once we practice, we shall be in position to get and to understand these formulas more and more. But some of them might not be in the logbook, so you need to get some of them in your near your fingers, such that when time comes, you're able to do them. Then for standard deviation, that is very simple. We get just the positive square root of variance. That is what gives us standard deviation. So I think let us do an example. We are saying a random variable x has the following distribution. Probability of x equaling to 0 is equal to probability of x equaling to 1, and that is 0.1. Then probability of x equaling to 2 is 0.2. Probability of x equaling to 3 is the same as probability of x equaling to 4, and that is 0.3. So what we are going to do is to have this information in table form. Then that would guide us on how to find mean and variance. So that is our table. So who can explain this table? Who can take us through the explanation? So we are fearing it since it is the first one. Okay, let me take it up. So we are beginning by having our x values, which are given in here: 0, 1, 2, 3, and lastly what? 4. So that is a column 4. Is it a column or a row? Vertical. A row. So we have x equaling to 0, 1, 2, 3, and 4.
It's a row.
Yes. And then they have given us their probability values. So probability of x equaling to the smaller x up. So in the question, they said probability of x equaling to 0 is the same as probability of x equaling to 1, and that is 0.1. So that is why we have a 0.1 here, and as well a 0.5 here, a 0.1 here. Then still in the question, they said probability of x equaling to 2 is 0.2. So that is why here we have a 0.2. Then probability of x equaling to 3 was the same as.
Guys also seeing the network issue.
You are not hearing? Are we hearing very well?
Yes, sorry, just that I'm breaking up, but now it's okay.
Okay. So probability of x equaling to 3 was equated to probability of x equaling to 4, and that is 0.3. So that is why we have 0.3 on 3 and 0.3 on what? On a 4. Then now, before this one comes in, because it was in table form, we are supposed to first know when I'm finding the mean, what is the formula for mean? So the formula for mean, I need to sum up x times probability values. So this formula is what makes me create another row for x times probability of x equaling to small x. So in there, I'm going to get 0. I multiply it by 0.1. And that would do generate for us a what? A 0. Then I get 0, I get 1, I multiply by 0.1. So still that would make no change. It would remain as 0.1. Then I get 2, multiply it by 0.2, and that gives us 0.4. Then I get a 3, multiply it by 0.3, that gives me a 0.9. Then get my 4, multiply it by 0.3, and that gives me 1.2. And later when I add up these values here in this third column, I'm able to get the expectation, or what we call the mean, of a random, a discrete random variable. Are we okay about the mean? Can I proceed?
Yeah.
Okay. Then now we get to expectation, and we know that the formula for expectation, we need to find the formula for variance. We need to find expectation of x squared minus the mean as well squared. But the expectation of x squared, we said we have to sum up x squared multiplied by the probability values. So now what would that mean? That we need to create a row for x squared times probability of x equaling to small x. So which is here. So still we get back. So we now first get x and square it. So we get 0 squared. That generates for us a what? A 0. Then we multiply it by 0.1. And that would give us a what? A 0. So still we get 0.1, 1 squared, and it remains as 1. We multiply it by 0.1, and then it still gives us a 0.1. Then we get 2 squared. So what is 2 squared?
4.
Then we multiply it by 0.2, and it gives us 0.8. So we get 3 squared, which is 9, multiply it by 0.3, and we get 2.7. Then we get 4 squared, which is 16, multiply it by 0.3, and that would give us 4.8. So when we do the summation of the 4th row, it only gives us expectation of x squared. So it gives us this answer here. So we need to get the variance to subtract the mean. Let us do that on our slide here. So we are saying expectation, so mean is summation of x times probability of x equaling to small x. So we add 0 plus 0.1 plus 0.4 plus 0.9 plus 1.2. And those with the calculator, what would that value be equal to?
$2.6.
So that would be 2.6. Then now with variance of x, we are saying we are going to sum up this minus this squared. So the summation of x squared times probability is 0.1, 0 plus 0.1 plus 0.8 plus 2.7 plus 4.8. Then we subtract 2.6, which is the mean. So we get it from here, substitute it here, and then square it. So when we do this and substitute everything in a calculator, we are going to be able to get our variance as 1.64. So somebody with the calculator can just check to prove whether our answer is the right one.
That's right.
Okay. Then if we wanted to get the standard deviation, we just find root of 1.64. That would be for standard what? Deviation.
Deviation. So how many decimal places?
And record to 4. So which answer are we getting?
1.2806.
And then here you can say 4 decimal places. Okay. So you can be interpreting this question as I briefly come back. So are we done interpreting the question? So the first part, we are asked to find the value of the constant k. And then after, we find the expectation of x. And thirdly, the value of x. So what are we going to do first? What are we going to do first?
We substitute the x values
We
into that kx.
into the kx.
Yes, then you sum it to 1.
Okay. But remember, there are 2, so we have values running from 1 to 5, and then 6 to what? To 9. So they have different what? Functions. But for each, so for 1 up to 5, we are going to substitute in k what? In kx. Then for 6 to 9, we are going to substitute in k into 10 minus x. Yes. So, but that one is better done when we are using a table. So it is better to draw a table. So when we draw a table, this would be x, which we are saying runs from 1 up to 9. But from 1 up to 5, we are going to substitute in k x. So when x is 1, what would be the probability?
K.
K, because we get 1 times what? 1 times k. So when x is 2, we shall have 2 what? 2k. Yes. Up to when it is what? It is 5. So when it is 5, as we can see in the table, so it will still be 5 what? 5k. So what happens when we get to x equaling to 6?
Use k into 10 minus x.
So that would be 10 minus what? Minus 6. And what is 10 minus 6?
4.
4. So that is why we have a 4k. Then when x is 7, we shall have 10 minus 7. And that would give us 3 what?
3k.
3k. So when x is 8, that is 10 minus 8, which would give us 2k. And then when it is 9, it is 10 minus 9, which would give us the value of k. So now when we have done this is now when we get to sum up. Here we say summation, probability of x equaling to small x, and we equate that to what? 1. Then we'll be in position to get the value of what?
1.
Of k. So can we do that in some few minutes and we see what k is equal to?
K equals to 1 out of 25.
1 out of 25. Samuel, are you getting the same answer? And the Nimung?
Yes. Same
Okay.
answer.
Okay. So that is what we do there. We sum up 25k is equal to 1. And finally our k is equal to 1 over 25. So if the question is still continuing, we can as well draw another table and then we substitute. And then do like what we did at first. This is for probability of x equaling to smaller x. So where there is k, we substitute 1 over 25. 2k would be 2 over 25. 3k would be 3 over 25 up to the last one. So this one here is supposed to be 1 over 25. So I think it was just some typing. What then remember we need to find the mean. So for mean we create a row for x times probability values. So we shall need to get 1 times 1 over 25, which gives us 1 over 25. 2 times 2 over 25, which gives us 4 over 25. Then 3 times 3 over 25, and that would give us 9 over 25. So it continues up to the end. So for mean, we are going to sum up these values here. So we are going to add 1 over 25, 4 over 25, 9 over 25, until we get to another 9 over 25. So we sum up those values, and those will be able to give us the what? The mean. Then for variance, we need expectation of x squared minus the mean squared. So we would first need to find expectation of x squared. So that is why here we create a row for x squared times probability values. So we get 1 squared times 1 over 25, and that would give us 1 over 25. Then 2 squared is 4 times 2 over 25, that is giving us 8 over 25. Then 3 squared is 9 times 3 over 25. So it is giving us 27 over 25. So we do that until the end, where we have 9 squared, which is 81 times 1 over 25, and that gives us 81 over 25. So for expectation of x squared, we add this row. I hope this table is okay with all of us. So silence means yes, so we can proceed. Okay. So to find, so we are beginning with the mean is expectation, summation of x times probability values. So we are going to add up this 1 over 25 plus 4 over 25 plus 9 over 25 plus 16 over 25 plus 25 over 25 plus 24 over 25 plus 21 over 25 plus 16 over 25 plus 9 over 25. So a calculator can do its work very fast, and then we get to see whether the answer here is the same as the answer from the calculator. So which answer are we getting?
Five.
5. Is it the same for all of us?
Yeah, it's the same.
Okay, so our expectation is what? Is 5. Then we'll go for the variance. So variance we are saying is expectation of x squared minus times probability values minus the mean. The mean is squared. So this would be when we add up the values of the expectation, the row of x squared times probability values, then we subtract the 5 squared. So we can quickly add what is in the bracket and subtract 5 squared, and we see which answer we are going to have.
Mm. 29.
29.
Mm.
Final answer. The one inside the brackets is giving us 29 minus this is supposed to be 25. I think it was also a typing error. And then the answer is supposed to give us a what? A 4. So 4 is our variance. Are there any questions so far?
No.
Okay. I think this brings us to the end of today's lesson. So please go to that unit on the site. You watch those more videos which are there for you to better understand and grasp this content of discrete random variable. So when we meet again, we are going to do some more examples, and then we'll be able to better understand and prepare ourselves well for whatever questions might appear on such topic. So otherwise, we meet again, and a nice evening to everyone.